All right, so in this lesson, we are going to learn about residuals and how residuals are another way to analyze scatter plots and whether a linear equation is a good fit for our scatter plot and a good fit for our data. So your learning goal got kind of cut off. It was supposed to say I can, but I can make and analyze residual plots. There's a very short lesson in the textbook about this, and we needed more examples than what the textbook gave. So I found these notes, and I've seen residual question on the OST before, either on a practice or on an item release. So I figured we would go over it today because it's an easy concept. So it says, ignore the first paragraph because we did not really look at that. But residuals help to determine if a curve is appropriate for the data. So for us, we're mostly looking at linear models right now. When we get into chapter 7, we'll learn about exponentials, and then chapter 8 and 9 are about quadratics. A residual is the difference between what is plotted in your scatter plot at a specific point and what the regression equation predicts should be plotted. So you know how you have your scatter plot and you have your line of best fit? The points are not on your line of best fit, right? They're a certain distance away. Sometimes they're really close, sometimes they're further away. So the residuals tell you how far your data is from the line of best fit. And that can help you decide if it's a good fit or not, or if it's linear or not even. So the definition of residual, I would definitely box this and star it and highlight this. So a residual is your observed y value minus your predicted y value. By observed, they mean what was in your data, so the actual value that you got from your table. And then the predicted y value is the y value from your equation. So it's the actual minus the equation. A residual is the difference between the scatter plot and the regression line. It is the vertical distance from the actual plotted point to the line. You can think of a residual as how far the data fall from the regression line, sometimes referred to as observed error. A residual plot is a scatter plot that shows the residuals on the vertical axis and the independent variable on the horizontal axis. So your x, or this axis, is still your x, but then the y-axis is how far your points are from the residual, or from the line of best fit. So we'll learn how to do that on the next few pages. So for this one, to determine if it's a linear model, it says when points are randomly placed above and below the x-axis. If it's nonlinear, then the points will follow a specific pattern resembling a curve. So for the first one, this is random and no pattern, so it is linear. So you can just say random / linear. But for these two, it has a U-shaped pattern. So these two are both curved. There's a pattern. So it's nonlinear. So if you see a pattern, it's not linear. If you don't see a pattern, then it is linear. And the idea also, if it's a good linear fit, then you will have the same points above the residual as you do below. Or maybe not necessarily the same points, but the same distance above as the distance below, like the sum of them. And they should, like if this is 1 and that's -1, all of the values should end up being 0 because that's how we make our line of best fit. It goes evenly through all the points. Okay, so on this page, we're just going to say linear or nonlinear. So for part A, do you think it's linear or nonlinear? Linear or nonlinear? Alex?
Nonlinear?
Why?
Because it's curved.
Yes.
Why?
They can't see you. It's okay. B, linear or nonlinear? What do you think, Molly?
Linear,
Why?
because it's not curved or inverted.
Yeah, there's no pattern. So you could say random. And C, Claire? Yes. All right. And then which of these two is a good fit? Carson? Or because, how do you know it's linear? Yes, so they're random.
What is a bivariate data?
Bivariate, that means two variables. Bi means two.
Oh.
Also, this doesn't necessarily have to be linear. It can be, like you can have a scatter plot that looks like this, and then your model can be quadratic, but your residual will still look like this because it's the same, you're getting the same distance from the points to the line of best fit. So if it, just because it just means it's a good fit for your model. But anyways. Number 3, after performing an analysis on a set of data, Jackie examined the scatter plot of the residual values. Which scatter plot indicates the best linear fit for the data? Which one has the best linear fit? Raylan? Yes. It's the one without a pattern. And number 4, how about for this one? Which one is the best fit? Alex?
One?
Well, it's not the one that looks like a line. That's still a pattern.
Residual has a pattern, so.
Residual is when the residual does not have a pattern.
No. 2.
Yes.
Because they're random.
Right. So which one of these would be an inappropriate choice? Quinn?
4.
Mm-hmm. All right. Now we're going to practice making residual plots. So in the first example, it gives us the equation y equals 0.5x. So they have the x values going in 5s and then the y values that they got from whatever they were doing. And then we have to find the predicted value, and then we'll subtract the actual, which is the observed, minus the predicted value, and then we'll get the residual value. So you don't need a calculator for this question. You just need to do 5 times 0.5, which is 2.5. So you're just dividing all the x's by 2, right? That's what that means. So 2.5, and then 10 would be 5. 15 times 0.5 is 7.5. 20 times 5 is 10. Sorry, 20 times 0.5. 25 times 0.5 is 12.5. And then 30 times 0.5 is 15. Okay, so I just figured out what the predicted value is using our equation. Then the residual is your observed minus predicted. So 3 minus 2.5 is 0.5. 4 minus 5 is negative 1. be careful with the ones that are -1, or negative, because you want to make sure to include the negative sign. 9 minus 7.5 is 1.5. 7 minus 10 is -3. 13 minus 12.5 is 0.5. And then 15 minus 15 would be 0. So our x-axis is still the same x in our table. So since it's going in 5s, we'll go ahead and make our x-axis go in 5s. So 5, 10, 15, 20, 25, and 30. And then our y-axis will be based off of the residual. Since your residuals go up to -3, so that's the furthest away from 0 it is, we want to make sure that y goes to -3. So if we just go in like ones, so -1, -2, -3. And then up here we'll do 1, 2, and 3. Okay, you just want to make sure you set up your y-axis so that your residuals will all fit. All right, I'm going to put the residuals in red. So the residual at 5 will be 0.5. So at 5, I'll put a point at 0.5. And then at 10, the residual we got was -1. So at 10, I'll put a point at -1. And then at 15, it's 1.5, which is between 1 and 2. At 20, the residual is at -3. At 25, it's at 0.5. And at 30, it's at 0. Okay? Does the residual plot suggest a linear relationship? So do you observe a pattern, or does it seem to be more random? So this is that we use the linear equation to model this. What do you think? Huh? It is random, yes. So that means, yes, a linear model is a good fit. So yes, random plot. You could write a full sentence if you want. Okay, now number 2, you don't have to do it this way when you do your homework, but I'm gonna teach you guys a little calculator trick in case you want to use it. Okay, so this is totally optional. If you don't remember it at all when you get home, that's okay. You just do it the way we did the other one. So you would just like plug in each value individually into your x and then figure out the predicted value. But I'm going to show you a calculator trick that we didn't get to in chapter 4. So you're going to go to your y equals, clear whatever's there, and you're going to type in the equation. So the equation, remember your y equals is at the top left. Okay, so right here is your y equals. So what's our equation? -0.4x, -0.4. The x button is right beside the green alpha button, plus 16.3.
Wait, where's that?
Right beside the green alpha button, plus 16.3. Okay, now you're going to look at the table. I'm just going to do one thing because I was doing this in the other class, and I want to make sure that this is back to normal. So ignore it. Okay, I will show you. So second graph is the table. Your table should start you at 0. If it doesn't, if it's close to 0, that's fine. You just scroll down. Oh, you want to go the other way. Scroll down. Because you're going to write down all of the even numbers from 2 to 12, because that's what your x is. So you see how at 2, the y value that we typed into our equation would give us 15.5. So you write 15.5 for the first predicted value, and then you do all of the even numbers until you get to 12. You can scroll down. Don't scroll down too much, though, because Like some people just get like scroll happy and they just keep scrolling and scrolling and scrolling, and then they end up at like 500, and then I have to teach them how to get back to 0, which I can do. Only scroll to what you need to see.
I only know it's like 10 of them. Nope.
That's the wrong.
Nope. It's not. Why does mine only go to 10?
It doesn't. Scroll down.
I'm trying to. It's like 10.
Sorry. Question that.
It's just stuck at 10. Nope.
Okay, once you write down all your values, start calculating the residuals. Okay, you scroll over, and then you press the down. Okay, your table set is at odd. Did you or at out? Did you change it? Okay, now it'll go. I don't know why it's. Why are you asking? We will get to that on the next one. Okay.
Ooh, I can scroll down.
What are you doing to your back?
Chill on that bag.
Pretty sure he's trying to go out of the case.
So let's see. Let me know if you need help seeing what we are seeing. Okay, so predicted is 15.5, 14.7, 13.9, 13.1, 12.3, and 11.5. And then your residuals, you subtract the y minus the predicted. So that would be negative 10.5, 0.3, 12.1. That one is 9.9. And this one is negative 1.3. You guys can do these without a calculator. 3 minus 11.5 is 8.5. Negative 8.5.
Wait, so do we divide the residual minus the predicted?
Subtract. Yes. Don't divide.
Okay.
All right. So we're going to set up our x-axis going in 2s. 2, 4, 6, 8, 10, and 12. And then what do you think we should set our y-axis at? Any ideas? 3. Yes. Think away 3s. Because we need to get to 12. And we only have 4 tick marks. So we'll do 3. 3, 6, 9, 12. Negative 3, negative 6, negative 9, negative 12. All right, and then I will graph the residuals, plot the residuals in blue. So the residual at 2 is negative 10.5. So at 2, we're going to put a point at negative 10.5, which is right in the middle, right in between negative 9 and negative 12. And then the residual at 4 is 0.3. The residual at 6, we got 12.1. The residual at 8 is 9.9. The residual at 10 is negative 1.3. And the residual at 12 is negative 8.5. So what do you think about this one? Is this linear equation that we made for this table a good fit? Or somebody made for the table?
No, I think it's like curved. So it's like
It is curved, yes. There's a
pattern.
pattern, it's a U shape, so no, it's curved. Right, so this would be this is not a linear equation. They probably typed in it, and probably the R value would be closer to 0 than it is to 1. Okay, now let's try number 3. So go to your y, back to your y equals, and type this equation in. 4.9x plus 16.4 and go to table. Now you're going to have to scroll a lot to be able to see the numbers, but there's actually a different way to do this. So what I was messing with before I showed you the table was the table set. So if you go to table set at second window, so press second window at table set right beside the y equals and change the auto. Auto means it's going to just go negative infinity to positive infinity in increments of 1. And it's going to start you at 0. But if we change the auto to ask, that means we can type in the x values we want. So just go over to ask and press enter. Then go back to your table and you'll be able to type in all of the numbers. So 100, 90, 80, 70, enter, 60, enter, and 50, enter. If you need help seeing that, raise your hand. We have to start this at 0.
Okay.
Or else it's going to give us,
Wait,
this should say,
negative 4.9x or what? Oh, wait, never mind.
okay, just go ahead and type over it, 100, 50, 90, and then it'll start. Is that how you did it beforehand?
What do you mean?
I don't know how you had that. Do you guys already have numbers in your table? Oh, that's weird. That's weird. Yeah, you type in the numbers. So type in the numbers in your X. Press the 100, enter. And start writing them down. Okay, write them down and then find the residuals.
What do we do with the ones once we run out of room, like the ones that stop numbers in them?
What? You just go 100 to 50.
But like, there's still numbers below it. Other numbers.
And don't look at them.
Okay.
Just keep going. Changing our table set. Ask.
Wait, which one is the residual again? Is it the x and y?
The residual is y minus observed minus predicted. So y minus predicted. Subtract in the order that it's being taken. Right. Now, if you want to do this in your homework, you can either do the ask option or you can change your table set to auto. Or you can do neither. You could just calculate it one by one. It's just kind of nice because it does all the calculations for us. All right. So we've got 506.4. And then 457.4. 408.4. 359.4 are these numbers you guys are getting. 310.4 to 61.4. All right, and then if you subtract, your residuals would be negative 1.4. Honestly, you could do this without a calculator. I know the numbers look big, but it's actually not hard to do in your head. This would be 2.6. This one would be 6.6. Correct me if I'm wrong. This one would be 0.6. This one would be negative 5.4. And then the last one would be 3.6. Those all look good? Okay. Now our x's, we're going to start at 50. You wouldn't go 100 to 50. You'd go 50 to 100, right? It still has to be like least to greatest. So you would do 50, 60, 70, 80, 90, and 100 for your graph. And then how about the residuals? Yeah, I would go in twos. So 2, 4, 6, 8, -2, -4, -6, and -8. And then we put our residuals on. I'm going to do mine in red. So we have to go backwards in the table. Well, I mean, you could go forwards. You just start at 100. So 100, -1.8. So over at 100, you're down at -1.4. I mean, not 1.8. And then the residual at 90 is 2.6. So at 90, you're at 2.6. The residual at 80 is 6.6. The residual at 70 is 0.6. And then the residual at 60 is -5.4. And the residual at 50 is 3.6. Negative. Is that negative? No, it's positive. 3.6. So is there a pattern here? No, there is not a pattern. So this one would be yes,
It's because of that thing.
because there's no pattern. Okay, so the rest of this packet, including number 4 on the one we didn't do, is homework. So the next page plus the 2 pages that say homework, okay? So total you have 5 questions to do. 2 are ones where you make your own graphs, or 3 are 1. 4 you make your own graph, and the last one is multiple choice. Okay, that is it. Have a great day.
Do you want to advertise on this thing?